Right, I'm gonna show you how to do a problem, sample problem here in monadic predicate logic. We're gonna solve this using natural deduction. So with problems using natural deduction, strategy is really key. So first thing that I always do is look at my conclusion. First I'll just go over this problem here. We have three premises. Premise 1, 2, 3. This is a therefore symbol, so this signifies that our conclusion is here. There is something x that is Sx. So let's look and see if first thing we should do is look and see if this occurs anywhere in our problem. We can see it does here. So from there we kind of want to think about our strategy. You want to have a game plan, a strategy to get to that before you just start doing something. Ideally, you want to know what you're working toward. So it doesn't look like a conditional proof would help us, because if we assume this side and then arrive at this, I mean, that just gets us back to the beginning, so that's not going to really help. We could do an indirect proof, but it looks like the easiest way would be to just use premise 2 to build this half of the problem, and then we can eliminate that whole half through modus ponens, and then we're just working with this, and we can see we have an Rx here that we could use to get that, and then we'll do existential generalization to get our conclusion here. So let's do that. Let's start off with doing we'll do a flagging step to start here. So flag A and flagging step UG. That just means that the UG means that we're doing a flagging step so that we can use universal generalization to get it into that, to get it back into the variable state instead of constants. So we'll start here. We'll do our not PA, and that is universal instantiation on 2. Now, since we have a not A, if we just add QX, we can use conditional exchange to turn it back into that. So let's just do that. Not PA, add, a little wedge there, QA, and that is addition on 5. Now through conditional exchange, which gets rid of the tilde and exchanges the wedge for a conditional. So we got PA wedge, or horseshoe QA, and that's conditional exchange on 6. Okay, so with that we can just, we'll just discharge our flagging step after that. And that'll be UG 4 through 7, and that turns it back into, for all x, PX horseshoe QX, and then that's just the left hand side of our problem, so of our first premise. So let's do that to just get rid of the whole first half. We'll just do modus ponens, which gives us our right hand side of premise 1, and that's modus ponens 8, 8, 1. Now here you'll always want to do your existential instantiation first. because you'd have to, if we did our universal instantiation on this, then we'd have to use a new constant. We want to use the same constant. So let's do RB, since we have to pick a new constant. We already used flag A, so that is existential instantiation on 3. Now let's do universal instantiation on 9 to get RB horseshoe SB. We'll just use the same constant. That's UI9. Modus ponens will get rid of the RB, which gives us just SB. Modus ponens 11 and, whoops, guess you couldn't see that there. Modus ponens 11, 10. Now, all we have to do is existential generalization to get our conclusion. EG on 12. So hopefully that shows you a good way to think about strategy in these natural deduction problems. If you have any questions, hit me up in the comments section. Thanks a lot.